Okay, let's talk about linear equations and how do we solve linear equations and what even are they? Well, a linear equation is where you have a couple of algebraic expressions with some variables that are equal to each other. So there'll be a left-hand side and a right-hand side with an equal sign in between. For such a algebraic equation to be called a linear equation, then the variables can only have an index, like a power of 1. So let's have a look at some examples of some things and we'll see if we can tell if they are linear equations or not. This first equation here, 2x plus 6 equals x plus 1. Well, they are two expressions equal to each other. We could probably say, you know what, they are. And they're all two, they don't have anything higher than a 1 in these positions. So, yep, they're pretty good. That looks like a linear equation, I'd say. This next one, this blue one, x squared, well, it's already failed. With this squared here, that means it's not a linear equation at all. So that one is not. This next one is a little trickier and a little harder to see. If we have 1 over 2 minus 1 over x is equal to x plus 2 over 3, is that a linear equation? I don't see any indexes on these, but this one's the problem here. We know that x to the minus 1 is equal to 1 over x, and that causes it to not be a linear equation. So you have to be very careful to make sure that what you're looking at actually is a linear equation. Let's have a look at some examples. We'll start off nice and easy. Here we have some one-step equations. Here we have x minus 79 is equal to 153. Well, you've got to do the same process all the time. You ask yourself, well, what's the unknown? It's x. Is it by itself? No, it's not. What's happening to the unknown? Well, we're taking 79. So in order to get x by itself, we have to do a reverse of what's happening to it right now. So how do we get rid of minus 79? Well, we add 79 to both sides. And when we add 79 to both sides, we'll get our answer for what x is. Okay. Similarly, here I have x over 7 is equal to 10. Same questions. What's our unknown? It's x. Is it by itself? No, it's not. What's happening to it? What's being divided by 7? So what's the reciprocal or the opposite function of being divided by 7? Well, it would be multiplied by 7. So I'll multiply both 7 and I'll get that x is equal to 70. Okay, very simple when you only have a one-step equation. There's only one step until you get your answer. Sometimes you might have more than one step though. Let's have a look at the process for two-step equations. So here we have our first one. We've got 2y plus 4 equals 12. It's the same process. What's our unknown? Y. Is it by itself? It's not. What's happening to it? Well, when you start looking at what's happening to our unknown, you have to start by looking at what's happening closest to our unknown. The first thing that's happening to it, the closest thing, is it's being multiplied by 2, and then we're adding 4. Once we've identified the order in which things are happening to our unknown, we can work backwards. So the last thing, remember I said multiplied by 2 plus 4, is you work backwards. So the first thing we get rid of is that plus 4, and we'll get rid of that by taking 4 from both sides. Once we take 4 from both sides, we will have 2y is equal to 8. Now you can't stop there. You've got to ask yourself, is it by itself? It's not. What's happening to it? It's being multiplied by 2. So we do the reciprocal. We have to divide by 2 on both sides, and we end up with y is equal to 4. Okay, easy enough. There's just more steps involved. Let's have a look at another one. Here I've got negative 6 minus 2x equals 12. Again, same thing. What's our unknown? X. Well, what's happening to it? Well, it's being, firstly, closest to it, minus 2 is being multiplied by the x, and then we are taking 6. We've got a negative 6 here. So I do the reciprocal of take 6, which is add 6 to both sides. I'll get negative 2x is equal to 18. So here I want to try and get rid of what's happening to the 2. Now I kind of have two options here. I could do this where I have negative 2x and divide it by 2, and I would divide this side by 2, and I would end up with an answer of negative x is equal to 9. But that's not ideal. We don't really want, I'll make sure you can see it, I don't really want my x to be negative. I want to try to avoid a negative x. So what we're better off doing, instead of dividing up here by this 2, is we're better off actually dividing by negative 2. Now when we divide by negative 2, well, a negative divided into a negative leaves it as a positive. So our answer will be x is equal to negative 9. And this answer right here is preferable to having a negative x. Negative x is not going to help us much in the future. It's going to be confusing. So it's better to have your answer as positive x even if the answer is a negative. Okay, so that leads us up to our next sort of idea of any sort of multi-step equations, right? Now this one's only got 2 steps, really, but you could have multiple steps. Then it doesn't even matter. It's all about that same process, looking at what is happening to our x, or to our unknown, and how do we then reverse what's happening. That's really all you're doing here. So let's ask ourselves the questions. What's our unknown? It's x. What's happening to it first? Well, first I would have to add 1 to it, and then I'm dividing by 2. So let's work backwards. First thing we want to do is we want to multiply both sides by 2, and I'll get x plus 1 is equal to 22. Same questions. Is x by itself? Nope, it is being added with 1. So I need to take 1 from both sides. And when I do, I get my final answer of x is equal to 21. Okay, we'll do one last example. Here I've got my x as a denominator in the question. That is a little trickier to deal with, but it's the same sort of process. Okay, so we ask ourselves the question, what's our unknown? It's x. What's happening to x? Well, nothing's really happening to x here. In fact, the x is happening to something else. It is being divided into 4. And that's really tricky to undo if we're thinking just about what can we do to get x by itself. So we're going to ignore that for now, and we're just going to shift this x so it's no longer the thing that is acting on something else. So to do that, I'm going to multiply both sides by x. Okay, so multiplying both sides by x will leave me x being removed from my left hand side, and my x is being attached to my right hand side. Now I could have written it like this, 3 over 2 with an x there. That's okay. That means the same as what I have written in the white there, just so that you know. Okay, so I now look at it and I say, all right, well, what's happening to x? Well, it's being multiplied by 3, and then it's being divided by 2. So I want to get rid of that last bit first, so I want to get rid of the divide by 2, and to do that, I will multiply by 2. I'll get 8 is equal to 3x. Then I want to divide by 3 on both sides to get rid of the 3 on the right hand side. I'll do that, and I'll end up with my final answer of x being equal to 2 2/3. And while that is the correct answer, I want to just show you that it's not the best way to write it. We really want to turn this around so that it is written as 2 2/3 on the right hand side. We want our unknown, our x, to be on the left hand side by itself, and we want our answer to be on the right hand side. Okay, so that is working with linear equations and solving linear equations in single step, 2-step, multi-step examples.